All right, sorry guys, sorry. Here we go. Here we go. So we've over the last couple of days, guys, we've done a couple different things. We've looked at imaginary numbers and how imaginary numbers play into radicals. More specifically, radicals that have what underneath them? Okay, so let me say it again because I know you weren't listening. Or actually, yeah, you were hearing, but you probably weren't listening. Let me say it again. Over the last couple of days, we talked about imaginary numbers, right? Imaginary numbers come into play when we look at radicals that have what underneath? What kind of a number? A negative number. A negative number, yeah, right? Negative radicals lend themselves to imaginary numbers. We talked about that, right? So what I'm going to talk about now, guys, is how does the quadratic formula get into the mix with imaginary numbers? Because what does the quadratic formula have in it? Square root. So what potential exists? That the b squared minus 4ac could be a negative. Now, has that happened yet? No. But if b squared minus 4ac is a negative number, then the quadratic formula is going to produce imaginary roots. Do we agree with that? Okay. So what I'm going to do is this, right? I'm going to ask that you guys play the ABC, negative a, b squared minus 4ac, 2a game, and get me the results for part A. So go ahead, use your calculator, plug those things in, tell me what you get. All right, so if you've played your game right, you stored these in your calculator, right? What'd you get for negative b? 4, right? So that goes here. What'd you get for b squared minus 4ac? Negative 100. All right, so that's going to go here. And the 2a, and that's going to go here. Now, before we actually talk about this, all right, and again, I emphasize certain things on purpose in class, guys, right? This is an example of a quadratic equation, right? What makes it a quadratic equation? You got a square in it, and it's set equal to 0. If I asked you guys to find the solutions to this, what would be the very first thing you would do? Again, the answer to this should be automatic every single time. Polyroot it, right? Polyroot. Should be an automatic. Polyroot it. So if we were to polyroot it, what do I have? I have 1, -4, and 29. So if I were to polyroot it, I get the empty set, right? I get the empty set. Now, what does that mean when I get the empty set? There are no real solutions. Yeah, there are no solutions, right? And to be more specific, there are no real solutions, okay? So the calculator does have the ability, guys, to find imaginary solutions. And I'm going to show you what that looks like. So if we go to the exact same spots, the degree is 2, right? We have the option of changing roots from real to complex. Exact same setup. And now it gives me the imaginary solutions. So I have a solution of 2 plus or minus 5i. 2 plus or minus 5i. So anytime, guys, that I get the empty set when I do polyroots, what should I follow up by doing? Doing it the same way, except changing real to complex. Okay? Now, let's go back to this. Okay? Remember that when we use the quadratic formula, it's not enough to simply get our solution. Typically, we have to rationalize it or simplify it, right? So what did we say about this? Can I simplify this into something else? Well, yeah, we said that the square root of -100 can be rewritten as the square root of 100, bless you, and the square root of -1, right? So what's the square root of 100? 10. And what's the square root of -1? I. So this is 10i. So I can go back to this now, and I can rewrite this as 4 plus or minus 10i over 2. And check it out. What do all of these numbers have in common? A factor of 2. And so if I take 2 out of everything, I'm left with 2 plus or minus 5i, right? And our calculator was able to find that solution using complex roots of the polyroot function. Hey, quick question. Ready? Will this quadratic, if I were to graph it, cross the x-axis? No. Why not? Because there are no real roots. There are imaginary roots, right? Which means it will not cross the x-axis. What do I have to do first in B before I solve this problem? Set equal to 0. So I got to move over the 10x, move over the 4. All right, so I get this. And again, what I would expect all of you to do, and that's what Brianna's doing right now, is I would expect you to right away, bang, let's pick up the calculator. Let's see what we got for solutions right away. So I have 1, 6, and 11. One, 6, and 11. And hey, check it out. Did I change that to go to complex solutions right away, or did I keep it at real? What does it say? Is there a C in front of this? No, I kept it at real, right? Because what's going to happen the majority of the time? I'm going to have real roots, right? The majority of the time I'm going to have real roots, okay? So we should always check for the real ones before we check for the complex ones, right? Okay, so no real roots. So actually, if you want, you can actually what? Just copy this and just put a C in front of it. And there's your complex roots. Notice something about these guys. Are they nice? No, right? So watch what happens when we actually apply the quadratic formula now. All right, so my A is a 1, 6, and 11. Negative B is negative 6. B squared minus 4AC. Negative 8 over 2. All right, so there's my 3 pieces. X equals negative 6 plus or minus the square root of negative 8 over 2. Do me a favor, flip the page to, actually you don't need to. If I go a couple of steps ahead here, guys, our next lesson is going to be based on this word. This word's called discriminant, okay? I'm going to start using that phrase today, okay? A discriminant, guys, is nothing more than, ready? B squared minus 4AC. B squared minus 4AC, Cam, is the discriminant. So if I say, guys, what's negative B? You say negative 6. If I say, guys, what's the discriminant? You say negative 8, right? So this has a special name, okay? And we're going to do more with that next class, okay? All right, so we get to this point, right? Why are we not done? Because I can simplify this, correct? Let's break down radical negative 8. What am I going to break it down into? Well, I'm going to make it radical 8 and radical negative 1. So we know that much. But what can I do with the radical 8? Radical 4 and radical 2. So what do I have? I have a radical 4, I have a radical 2, and I have a radical negative 1. If that confuses you, it should actually make things clearer. Because what's 4 times 2 times negative 1? It's the negative 8 that we had, right? Why did we choose 4? Because 4 is perfect, right? Why did I take negative 1 out? Because I got to make it imaginary, okay? So what can I simplify? Well, the radical 4 is the same as 2. This is the same as I, so what do I have? I have negative 6 plus or minus 2I radical 2. Over 2. Why did I change the order of that, by the way? Where do we usually put the radical? At the end of a term. What do all of these 3 things share in common? A factor of 2. So I can take 2 out of everything, which leaves me a final result of negative 3 plus or minus radical 2. Oh, sorry, wait. I radical 2. If we go back to our complex roots, guys, negative 3 plus or minus radical 2I. Watch this. Negative 3 plus I radical 2 gives me that. Does that match one of the solutions that we got for complex? It does, right? And then negative 3 minus I radical 2, does that match the other solution? Yeah, because it was what? It was negative 3 minus, it was negative 3 plus, and there they are, right? So again, calculator will help you check your solutions here, even if they're complex, and even if they're not nice ones. Go ahead and try that one below. the only way that you can really mess this one up, guys, right, in terms of actually knowing if you did it right or wrong, right? You should know right away, did I do this right or wrong, okay? But the only way that that will get messed up is if in that first step you make a mistake, right? So I got to subtract the 7x. Negative 5 minus 7 is negative 12x, right? And then I got to add the 10, which gives me 40. So your A is 1, your B is negative 12, your C is 40. As long as you get to that point, you should already know if you did it right or wrong, right? Okay. So how do you know? Well, you go to your calculator, you did a polyroot, you got an empty set, so you threw a C in front of it, and you got a 6 minus 2i and a 6 plus 2i. So 6 plus or minus 2i should be our solution, okay? So we go to our calculator, and we do our negative b, and we do our discriminant, and we do our 2a, and those are the things that we should have gotten. And we take those items and we place them into our formula, and we recognize that this is the same thing as radical 16 times radical negative 1, which is 4i. So I have 12 plus or minus 4i over 2, which is the same as 6 plus or minus 2i. And we have our solution, all right? Now, the nice thing about the calculator, again, is it what? Allows you to go back and problem solve, right? I mean, if you made a mistake, you should be able to go back and find it somehow, some way, okay? Are we good with that? All right, last problem. So consider this parabola. Use the quadratic formula to find the x-intercepts and express your answers in simplest a plus bi form. Guys, were this to show up on a Regents exam, again, I know it says to use the quadratic formula, but again, we're going to go right to our technology. So 1, negative 6, 13. So there's my 1, negative 6, and 13. And we get the empty set. So go ahead. All right, so we go ahead, like I said, we put a C in front. And we have our solutions. So we're going to write them down. It's 3 plus or minus 2i. Right? Now I didn't cheat to get them, right? I mean, I got the answer. I know what the answer better give me, right? So A is 1, and B is negative 6, and C is 13, and it says use the quadratic formula. Bless you. I think it was negative 16 again, right? Yep. And so when we use our formula, we get that. Same breakdown as last problem. So there it is, right? And again, we had the answer right from the beginning. We went through it, used our calculator to help us get everything in the right spot. It's awesome. Use your calculator to sketch a graph. Use the window indicated. So guys, it gives you the window, negative 5 to 10, negative 5 to 20. What was it? X squared minus 6x plus 13. How do I change the window, by the way? Where do I go? Menu, there's your window and your window settings, right? So they tell me to use the window settings here. So that's the window settings I wanted to have. So all I got to do now is what? Get this thing on my paper. Give me a way I can do that. Give me some of the items of this parabola which are really important. The y-intercept, that's an important point, right? What's the y-intercept of this guy? Everybody? At the same time? 13. Right? There are no roots. Hey, what's another point on this parabola which is kind of important? The minimum, right? Yeah, so I can use the, if I really want to, I can go to analyze and find the minimum, right? And that's just doing this little process. So there's a minimum at 3, 4. And it looks kind of like that, right? Got the y-intercept, I got the minimum. There are no roots, right? If there were roots, those would be really important to get, right? But there aren't any. Oh, hang on a minute. There aren't any real roots. There were roots, they were just imaginary. That's why I can't see anything here, right? From your answers to part A and B, what can be said about the parabola whose zeros are complex roots? They don't cross the x-axis. I'm going to use a better word. I'm going to use the word intersect. Now, if you wanted to use the word cross, that's probably okay. I would understand what that meant, but intersect's a little more mathy. That's it for today, okay? That's it for today.